Welcome to Network Professionals. Hello everyone, I'm Engineer Javiria Oftab, CISCO Certified Instructor. Welcome back to our channel Network Professionals. In the previous lecture we will discuss about second chapter about PC assembly. In this lecture number 6 we will discuss about the chapter number 3 advanced computer hardware. First topic of this chapter is related to boot the computer. In this topic we will discuss about the configuration of BIOS and UEFI settings. Then describe post, BIOS, CMOS and UEFI. Next configure the computer firmware. In the second topic we will discuss the electrical power. Explain electrical power, describe wattage and voltage. Explain power fluctuations and devices that protect against damage caused by fluctuations. In the third topic we will discuss about advanced computer functionality. Explain computer functionality. Explain CPU architecture. Describe RAID. Describe common ports, cables, and connectors. Describe monitor characteristics. In the fourth topic we will discuss about computer upgrade. Select components to upgrade a computer to meet requirements. Select appropriate components to upgrade a computer. Select components for specialized computers. In the fifth topic we will discuss about protecting the environment. Explain safe disposal methods to protect the environment. Explain safe disposal methods. Let's start now the first topic, boot the computer. In this we will discuss about post, BIOS, CMOS and UEFI. What is post? When a computer is booted, the basic input-output system, BIOS, performs a hardware check on the main components of the computer. This check is called a power on self-test, post. If a device is malfunctioning, an error or a beep code alerts the technician of the problem. BIOS manufacturers use different codes to indicate different hardware problems. Motherboard manufacturers may use different beep codes. Always consult the motherboard documentation to get the beep codes for your computer. Installation tip. To determine if post is working properly, remove all the RAM modules from the computer and power it on. The computer should emit the beep code for a computer with no RAM installed. This will not harm the computer. What is BIOS and CMOS? All motherboards need a BIOS to operate. BIOS is a ROM chip on the motherboard that contains a small program that controls the communication between the operating system and the hardware. Along with the post, BIOS also identifies which drives are available, which drives are bootable, how the memory is configured and when it can be used, how PCIe and PCI expansion slots are configured, how SATA and USB ports are configured, motherboard power management features. The motherboard manufacturer saves the motherboard BIOS settings in a complementary metal oxide semiconductor, CMOS, memory chip. When a computer boots, the BIOS software reads the configured settings stored in CMOS to determine how to configure the hardware. The BIOS settings are retained by CMOS using a battery. If the battery fails, important settings can be lost. Installation tip. If the computer's time and date are incorrect, it could indicate that the CMOS battery is bad or is getting very low. What is UEFI? Most computers today run Unified Extensible Firmware Interface, UEFI. All new computers come with UEFI, which provides additional features and addresses security issues with legacy BIOS. UEFI can run on 32-bit and 64-bit systems, supports larger boot drives, and includes additional features such as Secure Boot. Secure Boot ensures your computer boots to your specified operating system. This helps prevent rootkits from taking over the system. BIOS, UEFI configuration. BIOS and UEFI security. The legacy BIOS supports some security features to protect the BIOS setting, however UEFI adds additional security features. Some common security features found in the BIOS, UEFI systems includes passwords. Passwords allow for different levels of access to the BIOS settings. Drive encryption. A hard drive can be encrypted to prevent data theft. LoJack. This is a security feature that allows the owner to locate, lock, and delete the device. Trusted Platform Module, TPM. This is a chip designed to secure hardware by storing encryption keys, digital certificates, passwords, and data. Secure Boot. Secure Boot is a UEFI security standard that ensures that a computer only boots an OS that is trusted by the motherboard manufacturer. Update the firmware. Motherboard manufacturers may publish updated BIOS versions to provide enhancements to system stability, compatibility, and performance. Early computer BIOS information was contained in ROM chips, and to upgrade the BIOS information, the ROM chip had to be physically replaced. Modern BIOS chips are electronically erasable programmable read-only memory, EEPROM, which can be upgraded by the user without opening the computer case. This is called flashing the BIOS. To download a new BIOS, consult the manufacturer's website and follow the recommended installation procedures. The second topic is electrical power. Wattage and voltage. There are 4 basic units of electricity that a computer technician must know. Voltage, V, measured in volts. V, the measure of work required to move a charge from one location to another. Current, I, measured in amperes. A, the measure of the amount of electrons moving through a circuit per second. Resistance, R, measured in ohms. O, refers to the opposition to the flow of current in a circuit. Power, P, measured in watts. W, the measure of the work required to move electrons through a circuit multiplied by the number of electrons going through the circuit per second. Current. A basic equation, known as Ohm's law, expresses how voltage is equal to the current multiplied by the resistance. V equals IR. In an electrical system, power is equal to the voltage multiplied by the current. P equals VI. Power supply voltage settings. On the back of some power supplies is a small switch called the voltage selector switch. This switch sets the input voltage to the power supply to either 110 volts, 115 volts or 220 volts, 230 volts. A power supply with this switch is called a dual voltage power supply. If a power supply does not have this switch, it automatically detects and sets the correct voltage. The correct voltage setting is determined by the country where the power supply is used. Power fluctuation and protection. Power fluctuation types. When the voltage in a computer is not accurate or steady, computer components might not operate correctly. The following types of AC power fluctuations can cause data loss or hardware failure. Blackout, complete loss of AC power. Brownout, reduced voltage level of AC power that lasts for a period of time. Noise, interference from generators and lightning. Spike, sudden increase in voltage that lasts for a short period and exceeds 100% of the normal voltage on a line. Power surge, dramatic increase in voltage above the normal flow of electrical current. Power protection devices. To help shield against power fluctuation problems, use devices to protect the data and computer equipment. Surge protector helps protect against damage from surges and spikes. A surge suppressor diverts extra electrical voltage that is on the line to the ground. An interruptible power supply, UPS, helps protect against potential electrical power problems and provides a consistent quality of power when brownouts and blackouts occur. Standby power supply, SPS, helps protect against potential electrical power problems by providing a backup battery that is on standby during normal operation. This device is not as reliable as a UPS because of the time it takes to switch over to the battery. The third topic is advanced computer functionality. CPU architectures and operation. CPU architectures. A program is a sequence of stored instructions and a CPU executes these instructions by following a specific instruction set. There are 2 distinct types of instruction sets that CPUs may use. Reduced Instruction Set Computer, RISC. This architecture uses a relatively small set of instructions. RISC chips are designed to execute these instructions very rapidly. Complex Instruction Set Computer, CISC. This architecture uses a broad set of instructions, resulting in fewer steps per operation. While the CPU is executing one step of the program, the remaining instructions and the data are stored nearby in a special, high-speed memory, called cache. Enhancing CPU operation. Intel processors use hyperthreading to enhance the performance of some of their CPUs. With hyperthreading, multiple pieces of code, threads, are executed simultaneously in the CPU, so a single CPU performs as though there are 2 CPUs. AMD processors use hypertransport to enhance CPU performance. Hypertransport is a high-speed connection between the CPU and the North Bridge chip. The power of a CPU is measured by the speed and the amount of data that it can process. The speed of a CPU is rated in cycles per second, such as millions of cycles per second, called megahertz, or billions of cycles per second, called gigahertz. The amount of data that a CPU can process at one time depends on the size of the front side bus, FSB, also called the CPU bus or the processor data bus. Overclocking is a technique used to make a processor work at a faster speed than its original specification. Overclocking is not a recommended way to improve computer performance and can result in damage to the CPU. The opposite of overclocking is CPU throttling. CPU throttling is a technique used when the processor runs at less than the rated speed to conserve power or produce less heat. CPU virtualization is a hardware feature supported by AMD and Intel CPUs that enables a single processor to act as multiple processors. With CPU virtualization, multiple operating systems can run in parallel on their own virtual machines as if they were running on completely independent computers. Chapter number 3 will be continued in the lecture 7. Thanks for watching. Subscribe our channel Network Professionals.